Warning, are you feeling stuck despite your extensive knowledge? This frustration might indicate a dangerous disconnect in your learning process. Many overlook the hidden risks of transfer learning, and even advanced AI systems are not immune to these stress signals. Imagine trying to fit jigsaw pieces together, only to find they don't match, no matter how hard you try. You possess the skills, yet something feels off. This subtle disconnect could be costing you dearly. Picture this: you're confident in teaching a machine to recognize patterns, but when you apply that knowledge to a different model, everything falls apart. Your algorithms stumble, leading to frustration and confusion, leading to and how do you will always This is where the urgent warning signs of transfer learning emerge. Consider a scenario where you've trained a model to identify cats, but when you shift to recognizing dogs, cows, and sioux, you're left questioning why a seemingly simple task has spiraled out of control. These hidden risks can derail your progress and reveal the limitations of your model. As you confront the reality that your model may not be as robust as you believed, the tension escalates. Recognizing these stress signals is crucial for gaining clarity. What assumptions are you making? Is the new environment compatible with your skills? Every hiccup is an opportunity to refine your approach. You're not just transferring knowledge, you're evolving it. Don't ignore these warning signs, embrace them as stepping stones for growth. Reflect on your own experiences and consider how you can turn challenges into valuable learning opportunities. If you found this helpful, dive deeper into enhancing your understanding of transfer learning. There's so much more to discover. Dive deep, said Dio, 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 more. And then you Have you ever wondered why your A models sometimes fail spectacularly? It's not just bad luck, there are complex challenges in transfer learning that could be sabotaging your efforts. Imagine pouring hours into training a deep learning model only to watch it struggle with real-world data. Frustrating, right? But what if I told you there's a subtle issue at play that many overlook? In our excitement to leverage transfer learning, we often forget that not all knowledge transfers smoothly. Think about learning to ride a bike. You might master balance on a stationary bike, but as soon as you hit the road, everything changes. The same goes for your model might excel in one area but falter in another, leading to unexpected failures. Now, here's where it gets intriguing. The data you used to train your model could be biased. Imagine it trying to learn cooking from a recipe that calls for hard-to-find ingredients. Your dish might end up tasting off because the flavors don't match. If your training data does accurately represent the real world, your model's predictions are likely to miss the target. Have you noticed a well-trained model becoming overconfident? That's the transfer learning trap. It's like a student acing a test without truly grasping the material. The model thinks it knows everything until it encounters something new and struggles. Picture this: you're in a crucial meeting, relying on your A for insights. It seems confident, but underneath that bravado lies a shaky understanding of the data. You could be betting everything on a model that might not fully grasp the game. Let's talk about domain mismatch. Suppose you train your model on images of cats and then want it to identify dogs. Sounds easy, right? But if the model has learned the nuances of different dog breeds, it could misidentify them. You might have a wealth of potential, yet your model remains oblivious. So, what can you do? Start by diversifying your training datasets. Seek out real-world scenarios that reflect the variety your model will face. It's like training for a marathon. Mixing terrains will make you a stronger runner. And here's a crucial tip: always validate your model with new data. Don't just assume it knows what it's doing, test it in different contexts. A little skepticism can go a long way in A. Before diving into your next project, take a moment to reflect. Are you fully aware of the hidden challenges in transferring knowledge within deep learning models? Overlooking these issues could mean the difference between a breakthrough and a breakdown. As you move forward, remember that awareness is your greatest asset. Stay curious, question everything, and your journey in A will be not just successful but enlightening. If you found this discussion engaging, share your thoughts below. Let's tackle these challenges together. Imagine pouring your heart into building a powerful A model, only to find it faltering in a slightly different scenario. This highlights a crucial challenge in transferring knowledge within deep learning models. You might assume that once a model learns something, it can apply that knowledge universally. But it's not that simple. Transitioning from one task to another means the rules shift, and suddenly your once impressive A is at a loss. What's behind this issue? Many overlook the subtle nuances that define each task. Factors like context, data, and even minor details can throw your model off course. The tricky part is that many developers unknowingly set their models up for failure from the start. Think of a chef who excels in Italian cuisine. If you ask them to whip up a Thai dish, their skills might not translate perfectly. This mirrors how A functions. Knowledge doesn't transfer effortlessly. It demands a deep understanding of the new environment. What are these hidden challenges? At its core, it's about layers of abstraction. Each model learns to interpret the world through its unique lens, but when faced with a new perspective, it can struggle. The data may look similar at first, but it's the subtle differences that truly count. For instance, consider a self-driving car designed for city streets being tested on a country road. It may recognize cars and pedestrians, but what happens when a deer unexpectedly appears? That's a potential disaster in knowledge transfer. As we delve deeper, we uncover real risks. A mismatch between what the model has learned and what it encounters can lead to serious failures. Imagine relying on a health diagnosis trained solely on urban populations. What happens when it faces rural data? The stakes are high, and the implications are serious. Real lives could be affected. Every error due to poor knowledge transfer is a missed opportunity to harness the full potential of A. So, what's the way forward?